Hey everybody, here's the review for the start of the paper part of lesson 4.1 on polynomials. You can see that I have the answers in line, which is what I want to continue doing. Now this first one says find the intercepts of the following equation. So what you could do is you could think an x-intercept is when it's x comma 0, and a y-intercept is when it's 0 comma y. What you could do without even graphing it is to set y equals 0 for this top part. And so when you do that, that's going to be 5x squared plus 4 times 0 equal 20. So then the 4 times 0 just goes away because that's 0. And then when you divide by 5, you get x squared equal 4, which means x equal plus and minus 2. So then that's why this answer is plus and minus 2 comma 0 for the first part. For the y-intercept, you set x equals 0, and so that'd be 5 times 0 squared plus 4y equal 20. So this part goes away and you divide by 4, and so you get y equal 5. So that's why it's 0, 5. So that's what I would do if it's in a form like this. The other way would be you have 5x squared plus 4y equal 20. So then y equal, or let's say 4y equal negative 5x plus 20. And then negative 5/4 x squared plus 5. And you have that in your right form. And then you're going to want to do 0 of the graph for the y-intercept. I'm sorry, for the x-intercepts. For the x-intercepts. And then you want to do the table 0 comma something for the y-int. So let's get that done. Negative 5/4 x squared plus 5. Okay, so we want the x-intercepts, and you can do analyze. 1 is 0 of the graph, and go between here and there, which is negative 2, 0. And again, 0 of the graph between here and here is positive 2, 0. And then you want this one, and I said go to the table and go to where x is 0 and then y is 5. So those are two approaches for that. Now for number 2, it says if it's even multiplicity, then it would touch, not cross. So as an example, it could go like this, or it could go like lower, but it touches but doesn't cross. So you can have one on the right and it touches like that or like that. So the easiest way to think of it, like usually use x squared as your function to test when it's even, and x cubed when odd. So those would be like variations or translations of x squared. So this one's probably like x minus 3 squared, and this one's probably like negative x plus 1 squared. So at any rate, it actually just touches the x-axis in one spot and bounces off. Okay, now on this one, when you're talking about your even integer like x squared, we said from the notes you'd think of like -1, 1, 0, 0, and 1, 1. So that's if it's even. If it's odd, like x cubed, that'd be -1, -1, 0, 0, and 1, 1. So you can see out of these choices, so forth, what it had to be. Number 4. So this one says 4 minus 7 over x. This part is rational, and so it's not a polynomial. The 4 part is a polynomial, but the -7 over x makes the whole thing not a polynomial. And if you need an extra explanation, it's since it could be written as 4 minus x to the -1, 4 minus 7x to the -1, and this is not a non-negative integer. We said all the things have to be, all the indices or powers or exponents have to be non-negative integers, like x to the 0, x to the first, x squared, etc. Okay, now on this one, you look at your high-level stuff like ignore this 5 in front, ignore the leading coefficient, and translations. So on this one, you just want to think x squared, and then there's another x squared, so that's x to the 4th. So that's a polynomial of degree 4. So just ignore those extra numbers. On this one, you just have to graph it, and one of the things to look at would be that you would have -1, 3 is the turning point. You could probably find that from here. 5 parentheses x plus 1 to the 5th power plus 3. So there's your turning point. You can look in the table also. Whoops, -1, 3. Okay, right there. Okay, and so that's the A graph. Now, if you need to compare graphs, it's not slanting down, and this one has y-int that's 0, -2, and this one has y-int that's 0, 8. So look at your table, and you want the one with 0, 8. So that's what we want. Okay, on your next one, you're doing a transformation. Now this could be rewritten as -x minus 3 to the 5th plus 2. So this would reflect the x-axis, and it'd be right 3, and it'd be up 2. That's kind of like a review from an earlier class. Look left to right when it's decreasing in power like that, where you have x to the 5th, x, all the way down to the number. So reflect, and then this negative sign means right, and this plus sign means up. And so then graph it on your calculator, and it'd be this one. Okay, now this one is a little bit harder than the others previously. It says form a polynomial whose zeros in degree are given. So what you'd first do is make this x plus 1, make this x minus 0 or plus 0, it doesn't really matter, and then make this x minus 2. Now what I'm going to do is I'm going to rewrite that. I don't like having the x in the middle, so I'm going to put that in the front. So what I really want is like this, and then use FOIL on the second and third terms. So x times x is x squared. This x times negative 2 is negative 2x. The inside is x, so this was FOI. And then 1 times negative 2 is negative 2. Then you want to combine your terms that are like terms. So negative 2x plus x is negative x. And then you want to distribute. So you get x cubed minus x squared minus 2x. And sure enough, that does match what we wanted. So I would end up putting the x in front, and then I'd do FOIL for this part, and then distribute. Okay, here you want to do the same thing, but what you got to watch out for is this says multiplicity 2. So for the first one that's multiplicity 1, you just do x minus 1. Or you could say x minus 1 to the first. Now this one, you'd say x plus 4, and then you put squared. Notice it says degree 3, and so you can think 1 plus 2. And so that's how you know it's going to be right. From there, you've got to have x minus 1, expand this part, and so you have x squared plus 2 times 4x plus 16. Remember, you do the first term squared, you double the product of the middle parts, and then you do the 4 squared. So this would be x squared plus 8x plus 32. And then at this point, I distribute, I'd say multiply x by everything. And then I'm going to say plus, and then you got to change all these signs. I'm actually going to put parentheses there just to make sure I don't make a sign mistake. So I put plus, and then I distributed the negative 1. Now, did I really need to do that? No. I could have just had x cubed plus 8x squared plus 32x, and then said minus x squared minus 8x minus 32. The reason why I did it is because sometimes you have to have a minus sign there that affects all the rest, but not in this problem. So now you want to combine your like terms, and x cubed is all by itself. 8x squared minus x squared is 7x squared. So that's why I put circles around those. And then I'm going to just underline that. whatever convention you want to do for like terms, whether you want to use a box or underline it or whatever, just make sure you're doing the right thing. 32 minus 8, that's 24. Oh, I'm not sure why I put 32 there. That's a mistake. I should have kept that as 16. So that means this should have just been minus 16 also. Oh, and because of that one mistake, this had to be 16x. Dang, that's messy. And then 16x minus 8x gives you 8x. And then minus 16. Okay, which does match what we were expecting. Sorry about that. If you want me to redo that one, I can. X minus 1 first, x plus 4 squared, x minus 1. This would be x squared plus 8x plus 16, because you got to double the middle and keep that one squared. Then we want to distribute, so it's x cubed plus 8x squared plus 16x. And then do minus x squared minus 8x minus 16. And then 8x squared minus x squared is 7x squared. And then 16 minus 8 is 8. And then minus 16. So this looks cleaner. Sorry about that mistake, but it happens. We learn from mistakes. Okay, on the next one, they want the end behavior of this function. The first thing is, you notice for the real zeros, you just flip your sign. So if that's x minus 6, this will be 6. If that's x plus 5, it'll be negative 5. Now, the multiplicity of the larger 0 is 1, since you have like x minus 6 to the first, and on the other one, that's since you have x plus 5 squared. So, and then the common sense part, if you have a number line, negative 5, and then 0, and then 6. This is considered the smaller, and this is the larger. Oh, shoot. Okay. So I put a little number line. I put negative 5, 0, 6. So the negative 5 would be the smaller one, and 6 would be the larger one. And it says the multiplicity of the larger is 1. And that's because it's x minus 6 to the first power. And the multiplicity of the smaller one is 2, and that's since it's x plus 5 squared. So now because of that, this part would be crosses, and this part would be touches. Because if it's 1, it's cross. If it's 2, it's touch. So for the larger, it's crosses, which is multiple choice down here, and on the other one, so that's since it's 6. This other one, it's going to be touches. Now if it's like if it's based on x minus 6, x plus 5 squared, think of that as x and then x squared, which is x cubed. And the maximum turning point is 3 minus 1, which is 2. Now, if you want to be really technical, I know you probably don't, but if it's x to the n, then the most is n minus 1 turning points. So I tried to start with our easy one, like saying 3, so it's 2 turning points. It's always one smaller. Then for this part, we want the power function. And again, if you start with negative 9, x minus 6, x plus 5 squared, we'd think keep your original part and then change this to x, change this to x squared. So this is negative 9x cubed. So that's how we get the power function. So the power function doesn't use translations. Power function doesn't use translations. Kind of like what I said before. Yeah. For degree, we ignore the leading coefficient, but for the power function, we keep it. Okay. Now for this one, it looks like the only real zero is 4, because this x squared plus 4 part is imaginary. So let's graph that. Negative 7 parentheses x squared plus 4, and then x minus 4 to the third power. You only have one x-intercept. Even if you were to zoom out, you only see one. Okay, so the x squared plus 4 is the only part that's imaginary, so you only have one real zero. Now the multiplicity of that is 3 because it's x minus 4 to the third. So that's your 3. So because of that, it crosses. So that's the multiple choice part. And then the maximum turning points. Okay, so on this one, you're going to think negative 7 x squared, ignore the translation, and x cubed. So when you think of that, that'd be negative 7x to the 2 plus 3, which is negative 7x to the 5th. So for the maximum turning points, it'd be 5 minus 1, which is 4. Now, in this case, we don't really have that many turning points because we only have one x-intercept, but that one's the maximum number of possible ones. So that's how you get that. And again, I guess I have the work here for this also. The power function is just negative 7x to the 5th. You take off your translation part. Okay, now on this one, you have a graph given, and it has several answers. You want to know which one might have the given graph based on this information. So on this one, I'd probably just graph each of your multiple choice, graph A through F, and then compare it. So if you graph negative parentheses x minus 1, x plus 5, x plus 1. It's down, up, down, down, up, down with our correct numbers. And so A was correct. If we go to B, now that looks weird, looks suspect, because it has a half, but it might actually work out. So let's go to F2. I am going to put 0.5 instead of 1/2. It's just a personal preference. And then x squared minus 1, and then negative 5 minus x. Let's see what happens. So notice we don't have any particular y-intercept given, so it could have been any of them. But the question is, does it go through negative 5? Yes, it does. Does it go through negative 1 and 1? Yes, it does. So even though these graphs are not the exact same thing, it does go through the x-intercepts. So compare your x-intercepts and your orientation. Okay, for C, we have negative 1/2 parentheses x squared minus 1 squared, and then x plus 5. On this one, this is the third one. Based on going down first, and then this part having to be above, it's not this because this little part went below the x-axis. And so part of, well, the y-int part is below the x-axis. And just continue doing that for these others. I'll remove C, so I'm going to remove F3. Now for this one, x squared minus 1 and negative 1 minus x over 5. Okay, well now we're back, because this is a negative 5, this is a negative 1, this is a 1, and it's above. And so that did work. And then these two, so for E, negative 0.5 x squared plus 1 x plus 5. That one has a problem down here. So again, the y-intercept part. And if I make, oh, I forgot to put this parentheses in there. Okay, but it still has a problem. And then if I go to F, half, and then x squared minus 1, and then x plus 5. Again, it's too low, so that's the problem. Alright, so that's how you do that one. Just eliminate choices and compare it. And the y-int. Okay. So we compare the x-intercept, the orientation, like was it going up or was it going down, and then the y-intercept. Okay, now for this one, this is going to be one of your longer questions. So what you do is do your end behavior first, and so you think x times x squared, and that's x cubed. Then this was from being x plus 10, x minus 2 squared, and so you just flip your signs. Now for the y-intercept, it's apparently 0, 40. Let's graph that. X plus 10 and x minus 2 squared. Okay, I go to my table, and then at 0 it is 40. Okay, and then the zeros were the same as the x-intercepts. And then think of this as negative 10 is the smaller and 2 is the larger. Kind of like on that other problem. So for the smaller 0, which is negative 10, that's going to be multiplicity 1 since it's x plus 10 to the first. And so that means it would cross zero. Okay, cross's answer is right here. I would write this in, but that's me. Cross is at x equal negative 10. And then the other part, the larger 0 would be 2, and so that's going to be like multiplicity 2 since it's x minus 2 squared, and so that touches at 2. Okay. For the next part, you're going to want to graph it, and all of these pretty much have this similar, not exactly the same window. Now, what I notice is all go x min negative 15, x max 15, and x step 1, or you could just say auto on the calculator. But then these two go with negative 50 for y min, and these two go with negative 306. And looks like all have y max. I mean, all have the y step 60. Okay, so what I want to do, remember you can double click all of these, but that takes some time, or you can just go to window and then set them. So window settings, we want negative 15 to 15 by 1s, negative 306 to 50 by 60s. Well, that didn't work for A. So now we go to the window settings. This time we're going to change this to be, oh, and that changed all 59.9s. It's weird. This one we want negative 50 to 306 by 60. Okay, and that looks exactly like what we want. I'm going to go back to my window settings. Okay, that time it kept the scale exactly 60. Okay, but that was what we wanted for B. And now it wants you to approximate the turning points. And so one of them is this max, the other is this min. So the maximum, it says lower bound, so go on the left, go on the right. This is negative 5.999, so that's negative 6. So that's going to be one that's a maximum. The negative 10, 0, for mine doesn't make any sense. And the 2, 0 is probably the minimum. Analyze minimum between here and here. Yeah, that says 2, 0. So use those. Then it wants you to draw your graph, which is similar to like this one. They just won't have all the little tick marks. Dang, I don't like the page break. It's A, which is the first one. So it went up, down, up. Up, down, up. And you had to look for the correct y-intercept, because this is also up, down, right, up, down, up. So pay attention to the y-int. Okay, so for this function, again, you go back to like this polynomial originally. Well, that's going to be negative infinity to infinity for both your domain and range. So it can be as wide as you want and as tall as you want. Now you want to know where it's increasing. And so if you go back to this other part, we said the max was at negative 6 and the min was at 2 for x. So this was negative 6 for x, and this was at 2 for x. So this one was the max, this one's the min. Okay, so based on that, it's increasing on the left side, so this is the far left. It's also increasing on the far right, which is to infinity, and it's decreasing in the middle. So what you do is you see your negative 6 and you see your 2, and that's what we wanted. Okay, so that was like the longest question, probably. There's a few more. Number 14 is probably equally as long. So on this one, what you look at is negative 4 and then x cubed, which is why you turn that into x to the 4th. For your x-intercept, we see that it's from x plus 2. That means it's going to be negative 2. And from x minus 2 cubed, it's going to be positive 2. So those are your two x-intercepts. We know that we need to graph this one. Negative 4 parentheses x plus 2 and then x minus 2 to the 3rd. Okay, so that's our graph. And when we go to the table, we see 0.64. Table has 0.64. Okay, so those are your steps, and then this answer was the same as the xint. Then when you think of negative 2 and 2, -2 is the smaller, and 2 is the larger. So the smaller one is -2. That has multiplicity 1 because it's x plus 2 to the first. And so that cross. So you got to find where it says crosses. And then that happens at x equal -2. For the other one, the larger one, that's going to be multiplicity 3. Since it's x minus 2 to the third power. So that would also cross. So you can see over here it says cross. Now notice they have the order changed, but they're both cross. So that crosses at +2. So the smaller one is negative in this case, the larger one is positive. Now when we graph this, I'm going to do zoom fit in this case. Zoom fit is A. So mine looks like that. You can't really see this little bubble deal. Oh, you know what? Don't use zoom fit. These are your X's, these are your Y's. My bad. So you go to your window settings and you want -8 to 8 by 2 and -500 to 500 by 50. And now you should have a good graphing window. So that's your graphing window. And so then you know it's that graph. Now as far as your turning point, menu, analyze, hold on. What you can see in your table is some symmetry, and here's a 0, here's a 0. So somewhere between there it had to have a turning point when it went from low to high, back down to low. And so if we look at our maximum, menu, analyze, maximum, between here and here, our max is -1,108. And so your turning point is indeed your maximum. So we're not talking about where it changes from concave up to down, not where it goes from concave up to down. So just simply your maximum, and then that'd be your graph that's similar. Again, your domain would be -infinity to infinity. Your range has a certain stopping point, which was the 108. So that's why this is not -infinity, infinity, because your range is like as low as you want, and then this part of it was 108 because that's from -1, 108. So that's what we want for our range. It was increasing in the front. It was increasing here and then decreasing this whole way at different rates. but it's still decreasing. So this one was on the left, and this one was on the right. Okay, so again, 14 was one of your longer ones, and that's it. Okay, so it seemed like to me 13 and 14 were definitely the harder ones. So you might want to do some examples of that, because that seems like that would really benefit you. Okay, hope that helps.